Hi, folks. Thank you for joining us here at Root Health. And for our article reading today, our article today is called Scientific Research Limitations in Sport and Health Sciences and How It Applies to Stretching. The first part of this article, which we'll be reading today, skips the actual stretching part. We're just building up on limitations, on the subject of limitations in research in the sports and health sciences. This was originally from a discussion in the class Research and Decision Making in Medicine from the Masters in Biomedical Diagnostics program at Arizona State University, as well as my profession as a sports scientist. So, first part of this is problem or importance. So, science, or the product of that knowledge, which is derived by the scientific method, is in the public view primarily considered of the same quality across a spectrum of domains. As long as the words science, peer-reviewed, and other buzzwords are used, it must be true. I would propose that the public and, of course, the scientific community and those who work in the sciences take a more nuanced point of view, understanding the complexity of the health sciences and the challenges that research and experimentation in different domains present. Within healthcare, including the sports sciences, this understanding is paramount to making decisions on strategies. Goals of the scientific method. It is said that there are three main goals of the scientific method: description, prediction, and explanation or understanding. The focus of this presentation is directed towards one specific goal of the scientific method: prediction. Research experimentation as related to predictability. For research and experiment to produce the insights associated with a full understanding of a system, whether that system is mathematical, chemical, physical, or biological, and therefore properly predict the outcomes within that system, we need to reduce the variability within the experiment or research. This one aspect of research is paramount to producing understanding of decisions made within a certain discipline. So we're going to talk about certain disciplines now. Mathematics. In order to put into perspective research in health science and research, we should compare and contrast other domains of science. The first that we're going to talk about is mathematics. Math is the most concrete and therefore most comfortable of sciences. The reason: consistency. Math proves itself. For the most part, it needs no experimentation other than, well, more math, more equations. 2 plus 2 always equals 4. You can prove this by 1 plus 1 plus 1 plus 1. Did I say that right? Did I give enough ones? I give too many ones. If I hypothesize a certain outcome to an equation, this postulation can be proven by another equation. Ask yourself these questions. If you ask 10 math teachers a question, how many different answers will you get? When proving your hypothesis to a question, or to a hypothesis, how complex must your experiment be? How many times must you perform an experiment to produce a predictable result? How much has math changed in the last 30 years? Next, we'll look at chemistry and physics. There are laws of physics. Newton's laws of motions are without fail, hence why it's a law. If I drop the ball, it is very predictable what will happen. Physical laws act within chemistry as well. If I mix two chemicals with respect to environment and the amount of the chemicals, the same result will happen over and over. If I put heat to water, it is predictable what will happen at a certain temperature and pressure. If you ask, so now we're going to ask those same questions that we asked with math. If you ask 10 different physicists a question, how many different answers will you get? When proving a hypothesis, how complex is your experiment? How many times must you do it to provide a predictable result? And how much has chemistry the topic from school at least, changed in the last 30 years. There is a certain amount of homogeneity inherent in these domains. A pure chemical is always that chemical. Gravity is always gravity. Air resistance is always that and can be calculated. Consistency or homogeneity in research and experimentation in these domains produces what we are looking for from the scientific method, predictability. Now we're going to go into biology and a sub part of biology, microbiology. Microbiology is a little less predictable. Microorganisms have some variation. The laws of evolution apply, meaning that change is inherent in this scientific domain. There are some consistencies, such as dealing with protozoa and amoeba, but then we have viruses and new bacteria. And now we ask our questions. How many different answers will you get out of 10 microbiologists? When proving your hypothesis to an experiment, how complex must your experiment be? How many times must you perform the experiment in order to produce a predictable result? How many different species do you need to look at to find patterns? How much has this changed in the last 30 years? Now we are getting to our domain, the complex organism. In the health sciences, when trying to predict the outcomes of stimuli on a complex organism like the human body, the variation is incredible. We can identify patterns, but how do we get to those patterns? What we lose when moving toward a complex organism from a single-celled one is homogeneity. What we lose along with that is predictability. When proving your hypothesis dealing with human beings, how complex must your experiment be? How many times must you perform it? How many participants do you need? How do you account for individual differences like individual psychology and other unforeseen factors between your participants? How many laws are there in the study of complex organisms? This is why twin studies are so important. We get back some homogeneity, but only with 2 subjects. This should point to the difficulty involved in producing that homogeneity in studying complex organisms. So now we ask our same questions. If we ask 10 doctors about a topic, how many answers will you get? How much has nutritional science changed in the last 30 years? How much can we predict about the body from the Human Genome Project? And how much do doctors truly know about human physiology? And so we'll leave you with those questions to ponder. And hopefully we made a little bit of a point, but hopefully more stirred on a little bit of critical thinking about experimentation and predictability in the in the domains of scientific research into the sports sciences and health sciences. So thank you very much, folks, for listening today. And let me know if you have any questions or comments or anything like that. Thanks a lot.